this is a classic problem. This is one of these ones that I joke about this, but I guarantee will show up on a test, and I guarantee people will get it wrong. And this is like a set play. You should be able to look at this and get the right answer. So the idea here is that I've got a 12 kilogram box, a 4 kilogram box. I know that the boxes are accelerating upward at 2 meters per second. So the question is, first of all, what lifting force of lifting is required? And then I'm going to ask you about the forces between the two boxes. So what's the first step to solving any problem like this?
Force body diagram.
Free body diagram, perfect. And the way to do this is to start off by saying that we're going to treat the whole system as one. Treat as one big box. And then we'll take it from there. So what that says is I'll start off by saying I have a 16 kilograms, so 160 newtons going down, and I have a force of lift going up, and then I can apply Newton's second law, which says that sum of the forces is ma, so I'll have F lift minus 160 is 16 kilograms multiplied by A. Perfect. And in this case, F lift would equal 160 plus 16 times A, which, if I'm not mistaken, is, so what's 16 times, 32, perfect, is 32 newtons. So the net force is 192 newtons. Does that make sense? So 192 newtons is sufficient to lift these two boxes combined with an acceleration of 2 meters per second. I want to know what the force between the 4 kilogram box and the 12 kilogram box is. So what I'm going to do is carve out myself out a little space, draw a new free body diagram, and I'm going to say that the force of the bottom box on the top box, and then down I'll have the weight of the top box. Does that make sense? So that's the free body diagram. The idea there being that the bottom box pushes up on the top box with some force, and gravity pulls the top box down. We know this is going to be 40 newtons, and we don't know what this is yet. So we're going to just use Newton's second law, F equals ma. So I'm going to have mass of the top box, its acceleration is force, and I'm going to actually now label it as a normal force because that's the kind of force it is, minus mg. And what that gives me is the normal force is equal to ma plus mg, which looks like 4 kilograms times 12 meters per second squared. Did they mess it up? 2 meters per second plus the 10 meters per second from gravity would be 12, right? 2 plus 10 is 12. So that gives me a force of 48 newtons from the bottom, from the top block being pushed by the bottom block. So let's draw a free body diagram for the bottom block. So what forces are acting on this is where it might be interesting. What forces are acting on the bottom block? Like, what forces do I have acting on the bottom block? Somebody help me out here. Yeah.
You have gravity,
Okay, let me get back. Gravity, I have
the 48.
that. Cool. Hold on a second. I've got. Yeah, actually, I'm going to do this. That's a great answer. I'm going to do weight, which is equal to the 12 kilograms times 10 meters per second squared. And then I don't want a number, but I want words.
The second thing is like that you have because you're pushing 48 newtons up.
Okay.
It's
So
push down.
I'm going to say that. Remember over here, we found that this number was 48 newtons. So we had bottom block pushes top block up with 48 newtons. There'll be and I'm just going to call that for right now, the normal force from the top block on the bottom block. And are there any, but you're 100% correct, but I just want to label it this way. Are there any other forces acting on the bottom block? Yes. The lifting force. And we found that the lifting force, F lift, is 192 newtons. So now I can do some of the forces like we're familiar with. So I'm going to say F equals ma, or sum of the forces equals ma. So I have 12 kilograms being accelerated at 2 meters per second is equal to the 192 upward force minus the weight, which is 120, minus F of the top block pushing down on the bottom block. So this looks like 24, so I can rewrite this as the force of the top block on the bottom block is 192 minus 120 minus 24, and if I do that out, I'll get that 48 newtons that I had before. So I've confirmed that the force from the top block on the bottom block is equal and opposite to the force of the bottom block on the top block. Does that make sense? So you should be able to, you should always have a kind of a self-consistent solution. Any questions on that? Are you good? Any clarifications? Yeah. Did I make a mistake? Oh, sure. Let's clean that up. So what I say here is that Fn is equal to ma plus mg, and then if I'll put mass times a plus g, and that's going to be 4 times 10. 4 times, I want to have these things match up. 4 times 2 plus 10, which is 48 newtons. Is that better? Have more readable? Super.